All right. Hey, good morning, guys. Today is May 14th. This is where we should be on our schedule here. We're going to be doing 2 pages today. Some more practice. We're getting away a little bit in these pages. These pages here, we're going to do some more practice and applying what we've learned from the previous pages. Previous couple pages were heavy on concept and trying to understand and model. I will go through and answer the last couple of questions. We'll talk about those real quick. But page 397, 398 is going to be your assignment today. All right, so let's go ahead and let's look back at these models and stuff, and let's look at the bottom down here. So how are the number line area model for fraction, how are the number line and area models for fraction multiplication alike, and how are they different? Well, if we think about what we did with the area model, again, we have a length and a width and things like that, versus what we did with the number line showing the total value and stuff. We know that both ways show us a fraction of a fraction. That's the important thing, that no matter which strategy we take, they both show a fraction of a fraction, okay? If it's the number line, we can see that this is 3/4 of 1/3, okay? But it also shows the value of it in relationship to a whole. And so that's the other thing that's really important that they both do. They both show the value in relationship to a whole as well, right? Does that make sense? Okay. And so this whole thing is equal to 1, right? Okay. Same thing, whereas this whole line is equal to 1 as well. Now, how are they different? Well, there's multiple things we can look at as how they're different. Number one, these models, number line can actually go further, which we can break apart. It makes it a lot easier to see. Where the area model gets a little bit trickier, this way is really nice because it shows just a given whole fraction of a fraction, that section of it, which is really, really nice. They also vary in a lot of different ways. Talk about how they overlap each other. But the biggest thing is I really care about how they're alike. And the point is that the big point here is that they both do the same thing, just in a slightly different way, depending on how you think and how your brain works and what helps you see and understand this the best is the strategy that you should ultimately really take and apply. So you can formulate your answer there. Okay. What we will do is this bottom one here together, and you check your work with this one. Okay. It says choose any model you like to show 1/3 of 3/4. Okay. Well, if I'm going to show 1/3 of 3/4, so 1/3 of 3/4. Now I can go ahead and flip flop this. Doesn't really matter. But if I want to actually show what this is, 1/3 of 3/4, I want to show 3/4. Now I'm going to show what 1/3 of that is. So I'm going to go ahead and use the area model here. And again, this doesn't have to be a perfect square, but the idea is that in theory it is a square, but it doesn't have to be a perfect square. So I'm going to go ahead and show 3/4. So I need to break this into fourths. We can do that this way. Okay. And 3, that's 3/4 right there. I'm going to go ahead and shade this in. Okay. So that's 3/4, right? 3/4 of this. So now that's what I have. Then I'm going to go ahead and take 1/3 of it. I'm going to show 1/3 of it. So I'm going to go this way and show a third. There's 1/3, 2/3, 3/3, right? So but we only care about this 1/3, right? So we're only going to shade in 1/3. I'm going to go ahead and do this. Okay. So the idea here is that this, this black one here. This section right here, where you have both colors, That is our answer, okay? This is our product. This is showing that if these green are 3/4 of the whole square, the 1/3, this part here is 1/3 of the whole square, but it's also then showing that this square right here, I mean this rectangle right here, not the whole thing, just cut off here, these 1, 2, 3 parts, right? Those are those are 1/3 of the 3/4, because as you can see here is 1, 2, 3/3 of 3/4. This is just 1/3 of 3/4. So I have 1, 2, 3 parts, don't I? So there are 3 parts. But what is the value of each part? Remember, it's got to be in relationship to a whole. So as a whole, what do I have? I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, or it's 3 by 4, which makes 12. So 3/12 would be the answer. Now I can simplify this as well. I can simplify this, okay? So I can simplify this by going ahead and dividing each of these by 3. 3 divided by 3 is 1. 12 divided by 3 is 4. So 1/3 of 3/4 is 1/4. Now some of you might be able to look at this and say, well, yeah, if I take away, I break this down, of 3/4, well, there's only 3/4. So if I take them, since there are 3 of them, I could break them into 3 groups, right? Okay, and that would work as well, right? For sure. But we're really working on modeling this, and if you can see that and just instantly start thinking about that way, that's amazing. And that's awesome. That's why I want you guys to be able to see. But if you don't see that yet, that's fine too. The biggest thing is that we can model and understand what is actually happening here. Another important note here is that when we're multiplying here, the numbers are getting smaller, right? Because we're multiplying a fraction by a fraction, so my end result is going to be a smaller fraction. Okay. All right, so let's go ahead and go on to page 397. Again, if you need any of that repeated, just go ahead and move the video back. So 397, 398 is going to be not a lot, but plenty of practice kind of working through this stuff here. Let's look at this, okay? All right, we'll do the first few things here together, okay? Use an area model to find the product of 2/3 times 3/5. You can think of the product 2/3 times 3/5 as finding 2/3 of 3/5. Remember, we talked about how of and multiplication are the same thing, right? Super important that you think that way. Yep. Each row is 1/3 of a whole. So each row is 1/3 of a whole. Naturally, in one whole, there are 3/3, right? There are 3/3 in one whole, but we only are representing 2/3 here, right? So that's why these ones are this salmon pinkish color, right? Technically, before we had that, this whole line and this whole line would be this color, just like we did with my green colors or whatever on the last one. Each column is 1/5. Again, we have 1, 2, 3, 4, 5, right? Those columns are each 1/5, but we're going to represent 3/5. So that's why we have 3/5. That means all of these would be blue if we didn't have this. It's when we have both of them, these colors essentially merge, I guess, if you're mixing colors. And then they would create this new color, which is showing the actual value. Yep. The purple part shows 2/3 of 3/5. This is 2/3 of 3/5. Easy peasy. Because 6 out of 15 parts of the whole are shaded purple, the purple parts show 6/15. So again, there's 6, 1, 2, 3, 4, 5, 6 parts shaded. That's how we got our 6. And then there are 5 by 3, so there are 15 total parts. You can count them if you need to, but there's 15 total parts. We can multiply, it's an array. So we get 6/15. So naturally we could simplify that. And I like us to be simplifying this. Both these numbers are divisible by 3. This would simplify down to 2/5, okay, which would be the best answer for that. But if you just wrote this for now, that's fine, okay, in these particular problems, okay. So why are 15ths shown in the example model? Why are 15ths shown in the example problem? Well, how do we get to 15ths? Why are 15ths shown? Well, oops, my picture, our whole square here is broken into 15 parts because I have 5 columns and 3 rows, and they're broken into 15 parts. So that's why it's showing 15 parts, okay? Simple as that, okay? So I'm not gonna write that, but you want to write that if you're paying attention, it should be pretty straightforward. Now it says, use the model in the example to write each product. Okay, so let's think about this. Okay? If we're going to use this model up here to make sense of this, it's 1/3 times 3/5. 1/3 times 3/5. So if this is 3/5, this is our 3/5, right? Instead of 2/3, we're going to take 1/3, right? 1/3, which would be 1, 2, 3 parts. So this part here would not be shaded, correct? But these ones would, because it'd be 1/3. Or, you know what? We can just look at it this way. How about these blue ones down here, right? We can say that is 1/3 of the 3/5, right? So there's 1, 2, 3 parts. So it would be 3. And how many total parts are there? Oops. How many total parts are there? There's 15. I'm going to use a darker color so it's easier for you to see. 3/15, right? Which you could go ahead and simplify down to 1/5. Okay. All right. So now let's do the next one. 2/3 of 4/5. 2/3 of 4/5. So now we're keeping the 2/3 that are going horizontal, but we're going to add another column, aren't we? So essentially what we're going to look at is we have these 6 already here, but then we're going to add another column. So we're going to add these 2 more, aren't we? So it's going to be 2, 4, 6, 8. So that's going to be 8/15, and that cannot be simplified. Okay. Next, okay, what about 3/3 of 2/5? 3/3 of 2/5. Well, 3/3 would be all the way. Since this is my last one, I'm actually going to write on this. This would be 3/3 now, wouldn't it? The whole thing would be 3/3, correct? Now this is going down. This is going down to 2/5. So this is cutting off right here, isn't it? So 3/3 of 2/5 would be all of the 2/5, right? It'd be all of this. So it'd be all of this. All of it right here. But what is that in relationship to the whole? Well, this is 1, 2, 3, 4, 5, 6 15ths, right? Which ultimately just simplifies down to 2/5. Huh, that's weird. It just got right back to the same number. Why is that? Well, let's think about this. What is 3/3 equal to? 3/3 is equal to 1, right? Oops, you can't see that, sorry. 3/3 is equal to 1, correct? So the idea is 3/3 equal to 1. That means when we multiply this, it's going to be the same answer because 1 times anything is anything, right? Okay, so, but the idea is in the model, though, it would go to 6/15 based on what the model is showing, but 6/15 is the same as 2/5. So just don't lose sight of this fact that, you know, we're multiplying by 1, and so it's just going to stay the same. Okay? All right, choose yes or no to tell whether the denominator of each product, sorry, let me get this out of the way. So yes or no whether the denominator of each product is, yes or no tell whether the denominator of each product is 12. Okay. Hopefully you've started to see some patterns now. So quite honestly, let's get to this idea of seeing patterns and things like that. Hopefully you're noticing that the denominators getting to our original answers, right? I'm sure a lot of you have already noticed this, but our denominators are going to be the length and the width of that denominator, right? So, like I said, in this first problem, in this problem here, we have thirds and fifths. Thirds and fifths. Well, the thirds and fifths is going to be, again, the 3 by 5, and then gives our total part. Well, it's going to be 15, right? So we can just multiply our denominators to get that total part. So if we look at this, is our denominator going to be 12? Well, if there's 2 on one side and 6 on the other side, that means there's going to be a total of 12 parts. There's going to be a total of 12 squares. which means yes. What about this one here? Okay. Well, that's going to be 5 times 4, which is going to be 20. So no, that's not going to get me to 12, right? 4 times 3, yep. Okay. 6 times 2 again, yes, right? Okay. So it should be yes, no, yes, yes. And again, the reason why this is working now, obviously some of these might be able to simplify smaller than that, but the idea is that when we do this, the product will be that, and then we have to just simplify down, right? But the original solution would be that. Okay, some of you might be like, "Oh, Mr. Smonches, you just said that this is 1, and 1 times 5, 6 would just be 5, 6." Correct, but 5, 6 is also a 5, 6 is a simplified version or a more precise version of this would be 10 twelfths, and so you would get to twelfths. Okay, is the point. All right. Okay. All right, ladies and gentlemen. Okay, I'm going to have you finish these ones on your own. You have numbers 4, 5, and 6. If you have questions, I will be on this afternoon at 1 o'clock. Oh, sorry, 1 o'clock. Sorry, 12 o'clock, 12 to 1 o'clock ish. Okay, so feel free to jump on and ask questions. So numbers 4, 5, and 6. If you have questions from previous problems and things like previous pages, come on and ask. A lot of kids have been coming on asking not just of that day's work, which is totally fine. So yeah, we're down to the crunch time. We will not be, I will not be on tomorrow, Friday, to share these Fridays. We're not working online, but next Monday I will be online even longer, I plan on, because there's no new work. I'm going to use that as a day to try to help people finish up so they can turn their things in on Tuesday. Okay. All right. Hit me up if you have questions. I look forward to seeing you guys on in the afternoon. Don't forget to check on Mrs. Morris and Mr. Annan for their videos as well and stuff. Talk to you later.